Hello everyone, I welcome you all to a session on simple equation and compound equation. Right. So this is one of the important topics from point of view of your CAT examination and other management entrance tests also. Now simple interest, compound interest, this entire topic is based primarily on the understanding of percentages. So any student who has good understanding of percentages, who is comfortable with percentages, is expected to be good in SICI also. However, there are certain important aspects about simple interest and compound interest that the student should be aware of in these series of videos. So today is the first concept video. We'll take a few more, right? You'll be getting few more videos, concept 2, concept 3. I plan to do 3 videos like this, right? So you'll be getting them subsequently, right? Please ensure that you attend, you watch all the 3 videos, right? Because I'll try to cover the topic briefly, right? And of course, while discussing a topic, we shall be taking up the questions as well. Now, having said that, for a more deeper understanding, right, I would urge you all to go visit our nearest time center, right. We provide all kinds of courses, right, for MBA, for your bank POs, etc. Right, and we are the national leaders as far as the test prep industry is concerned. Right, so we have had great results year after year, right. So if you are someone who is looking to go for MBA, right, please go to the nearest center of time, right, and just hear it from them, right, what kind of batches they are running, all right, because in those regular classes you will be having, of course, a more detailed discussion. But for now, let's start with the session. So in this particular session, I intend to start with the first part of the topic, that is SI, simple interest. So I hope we all understand what do we mean by interest, why is it charged, how is it calculated and all that, right, what is meant by interest. But for the sake of all, I'll just take a very small example. Imagine there is a person who has taken a loan from bank and the loan amount taken is 1 lakh rupees. Now the person uses that 1 lakh fund for some personal use, right, for some kind of business use. Now the person promises the bank to pay back this amount next year. So next year he is paying back 1,15,000 rupees. So that means he is giving 15,000 extra. Now here in this example, this sum borrowed is called as the principal amount. The sum which is paid back is called as the final amount payable. We call it as final amount. Final amount paid, and the difference of these two is called as the interest. So thus one of the basic equations that we can write down in SICI topic is the interest on a certain sum for a certain amount of periods, a certain number of years, is nothing but the difference between final amount we represent by capital A minus the principal amount. So capital A minus capital P is going to be your interest. So this is one of the basic equations that shall be useful both in simple interest and also in the compound interest. But as I said, our current objective, this session's objective is to know more about SI. Let's start doing that. So when you come to simple interest, so what happens in simple interest is, simple interest, the way to calculate interest differs from the compound interest in the following way. In simple interest, one of the points to be noted is the principal amount is always constant. It doesn't change. So since the interest is always calculated on the principal amount, all right, I hope you know rate of interest and all are also there, that we did not take it up here, but there is this concept of rate of interest also. The interest is always calculated on principal amount, and since principal is constant, in SI, interest per year, every year, is also constant. So that means if someone says, I have borrowed some money under SI, and the first year I have paid 5,000 rupees interest, that means the 10th year also he will pay 5,000 rupees interest only. There won't be no change, there will be no change in the interest amount paid unless the principal is paid back, alright, unless the principal is paid back. So principal is constant, thus interest per year is also constant. Now one more thing here is, since interest per year is constant, we calculate interest for any year, for kth year under SI as, that is nothing but rate of interest R% of the principal amount. of the principal amount. So this is how we can find out the interest for any particular year. I write kth year because whether it's for the first year or the second year or the fifth year or the 10th year, it's all going to be same. The interest amount is going to be same only. So thus can I say, extending this point, interest over n years, if I talk about 5 years interest or 10 years interest, will be simply this expression added n times, which is nothing but n into r% of principal. Thus, next point, if I borrow p rupees at r% rate of interest, simple interest, r% per annum, for n years, in such a case, the final amount under SI is given as principal plus the interest. When I take out the principal common, I will be left with 1 plus n into r%, or we can write as r by 100. So these are some basic equations that we shall be making use of as far as your simple interest concept is concerned. Now we'll take up some examples also, as I said, right? But before we do that, one more small point to discuss. Consider the following case. I have lent some 10,000 rupees. I have lent it to two people, A and B. I have given some amount to A, some amount to B, not necessarily equal. To A, the terms of the loan are different as compared to B. To A, I am giving away the loan under SI at 12% per annum, and this is for 3 years. Whereas to B, I am giving the loan at 15% per annum, and this is for 2 years. But here it is given that even though the terms of the contract, the terms of the loan were different, the interest amount received from each of them is same. Interest amount received from each of them is same. Then the question is, how much was given away to A? How much was A lent? Alright, what is the principal for A? So the way to calculate it would be, if I assume A received A rupees, B received B rupees, such that A plus B becomes 10,000. Now here in this case, please notice, the condition will be the interest on A, which is nothing but 12% per year for 3 years, 36%. Will be equal to interest on B, which is 15% for 2 years. Both should be equal. You will get some relation for A and B. Now, if you have the relation for A and B, the ratio, you have their sum, you can find out their individual values also. So, basically this model of question will be of the type wherein the question setter would tell you the interest earned from each of them is same. So, when interest earned from each of them is same, can I write the general formula as, notice interest earned from each of them. Imagine there are k people. So, person 1, person 2, person 3, person k. Each of them is lent at R1%, N1 years, R2%, N2 years, R3%, N3 years, RK%, NK years. Let's say. Now, if such a condition is given that the interest from each of them is same, then can't we write R1 into N of P1, R1% of P1, sorry, let's write it this way, or N1 into R1% of P1 should be equal to N2 into R2% of P2 equal to NK into RK% of PK. So, here using this equation or set of equations, we can find out the values of or the ratio of P1, P2, P3 so on till Pk. We can find the ratio, alright, directly. This is one case, this is one example. Alternately, he might also say something like this. He would again say there are two people whom we have given away loan, 12% 3 years, 15% 2 years. But this time he would say the final amounts received from each of them. The final amount which is received from each of them is same. So, when he says final amount, the formula to be used is this. So, can we say here in this case it is going to be A into principal into 1 plus NR by 100 will be equal to B into principal into 1 plus NR by 100. So here again you can find the ratio of A and B using this particular equation, thereby you can again find the values of individual values of A and B. So if you have a condition like that where he says the final amount payable are equal, then this kind of equation will look differently. It will look like the final amount received from the first person is going to be P1 into 1 plus N1R1 by 100, which can be further simplified as, look at this, 100 plus N1R1 by 100. This will be same as P2 into 100 plus N2R2 by 100, which will further be equal to Pk into 1 plus NkRk by 100. And please note this by 100 will be cancelled out throughout and you will be finally left with something like this, equal to Pk 1 plus NkRk. Now yet again here we can find out the ratio of the principal amounts and hence we can find out what principal was lent to which person. We can find that out. P1, P2, P3 values can be found out. So this is the condition where the interest earned was same. This is a condition where the final amount received from each of them is same. Right? So these are some theoretical points that we have under SI. Now there are some more points which we will cover using questions. Sorry. Look at this. You can copy this all. Moving on. Look at this one. A certain amount under SI amounts to 48,000 at the end of 6 years and it amounts to 64,000 at the end of 14 years. Find the rate of interest is the question. So what I would suggest is you pause the video here, give this question a try, right? See what your answer is, right? And then you can watch the video. Now here he says a certain amount. So let's say this was some P rupees which was lent. Under SI amounts to 48,000 after 6 years, at the end of 6 years, 64,000 after 14 years. Find the rate of interest, let's say it is R%. So we know one thing in SI, depending on the rate of interest calculated every year, interest per year is constant. Let us say that interest per year is I. Let's say it is I. Let's take it as I. So in that case, what will happen? For 6 years, what will be the interest accumulated? 6I. And what is the final amount payable? 48,000. So we know 48,000, the final amount A is nothing but interest plus the principal, right? You recall that formula? We wrote I is equal to A minus P. That means A will be equal to P plus I. P plus the total interest. So similarly for after 14 years, what is happening? Interest will be 14I. Principal plus total interest will be equal to 64,000. So we need to solve these two equations and find P and I. We can do that. So when you subtract, P cancels out. 14 minus 6, 8I. 64 minus 48 is 16,000. So that means interest per year is going to be 16 by 8, which is 2,000. Now once we get this, we can find out P also. Substitute it back, 2,000 here, 12,000 will go away. So 12 will go on the other side, P will be 36,000. 36,000. Now once you know the interest amount per year and you know the principal amount, you can find out the rate of interest by using the following equation that I shared. Interest for kth year is equal to R% of P, we said. So what is I? 2,000 will be equal to R% means R by 100 of P means 36,000. So when you simplify 360, 36, okay. And now I think we can cancel out 4 on both sides, 9, this will become 50. So hence the value of R in percentages is going to be 50 upon 9 percentage. He's asking us to find the rate of interest only. So we'll get our answer like this. Had the question been find the principal amount, we are already done with that. So this way, without using the formulae, if you notice here, we did not use any formula except for this common understanding, right? Or if you want to call it a formula, this is the formula that we've used, right? Except for this, to solve this question. A general tendency for the students in this kind of question is to directly go for the formula P into 1 plus NR by 100 is equal to 48,000. P into 1 plus NR by 100 is equal to 64,000, and then you try to find the value of P and R and etc. It would be better. This way we are solving it as a simple equation question, right? I hope we are clear with this. Next, look at this one. A certain amount becomes 4 times itself in 12 years. Of course, this is under SI, okay? Just also consider that. Under SI becomes 4 times itself in 12 years. In how many years will this same amount become 7 times itself? Again, pause the video, try it out, see what your answer is. Consider SI as I said. So the best way to solve this question would be a simple understanding of simple interest, which is under simple interest, the increment in the final amount, the total money, alright, which is due, the increase in that is constant. For example, what I mean by constant is, for example, let us say the increase in 1 year was 10 rupees, increase for 5 years will be 50 rupees. Increase for 2 years will be 20 rupees. So that way it is uniform, right? It's not growing exponentially sometime, alright, initially it is low, no, nothing like that. It grows at a constant pace. Every year it will grow by a piece, right? 10 rupees, 100 rupees, 10,000 rupees, whatever, right? So that's a unique property of SI. So if that is the case, look at this. A certain amount he says, so let's say the amount was 100 rupees. So whatever is the given condition should work for all principal amount, it will work for 100 also. Let's take 100. A certain amount 100 I have taken becomes 4 times itself in 12 years. So one thing that we can note here is, over this 12 years, the interest that has accumulated is 300 rupees. Final amount minus the principal, which is the interest accumulated, 300 rupees. Now I just now said the interest accumulation in SI happens at uniform rate. So if 300 rupees is accumulated 12 years, so that means, can I say, in 1 year the interest accumulation will be 300 by 12, which is 25 rupees. So that means every year the interest that is getting added is 25 rupees, which is nothing but 25% of the principal amount. We can also say this because principal we are taking it as 100. Now coming to the question says in how many years will the same amount 100 rupees become 7 times itself? That means 700. So if 100 has to become 700, can I say here the interest accumulated is 600? And we know one thing, that each year the interest accumulation happens at this rate, 25 rupees per year. Let us assume it takes n years. So for this n years, interest accumulated will be 25n, which is given to be as 600. So thus the value of n can be calculated as 600 by 25, which is 24 years. This is what was the question. So thus we could answer it this way without again going for the formula. However, we could also solve it using the formula. I'll just try to briefly let you know how we can perhaps do it. A certain amount, let's say P, becomes 4P, 4 times in 12 years. So the formula is final amount is equal to P into 1 plus N. N is 12 years by 100. So in this equation, P cancels out and you can find out R. You can find that out. I'm not doing it, I'm just letting you know. Next, the same amount should become what? Should become 7 times. In how many years? Let's say n years. You know R. So here we can write 7P will be equal to P into 1 plus N, which is unknown, R, which is known, by 100. This is known, so hence we can find out N. I'm not doing this. This would be a slightly longer process if you'll ask me. We could do it directly, more directly like this. But I hope we are clear with this question. Moving on. Next, let's look at this. Atul lends a total of 40,000 rupees to Raj, Ranveer and Rambo, right, under SI. So it's simple interest. So 40,000 given to these 3 people. Let's call Raj as R1, Ranveer R2, Rambo is R3. R1, R2, R3. If the interest earned by Raj is R1, in 4 years at 20% is same as the interest earned by Ranveer R2 6 years at 12%, which in turn is same as interest earned by Rambo 5 years 18%. Then find the amount lent to Raj. If you remember, we are talking about exactly this case some time back. So let's assume the principal amount is P1 here, P2 here, and P3 here, let's say. So can we say interest is same? So what's the formula? P1 N1 R1 will be equal to P2 N2 R2 will be equal to P3 N3 R3. When you simplify, P1 into 80, P2 into 72, P3 into 90. So throughout, I think we can cancel out a 2. So it will become P1 into 40, P2 into 36, P3 into 45. I don't see any other common factor between the 3 numbers. So hence here we can say P1, P2, P3, the ratio of the 3. We have a formula in ratios, if you remember, we have discussed in one such video. Then x is to y is to z is directly 1 by a, 1 by b, 1 by c. So here it will be 1 upon 40, 1 upon 36, 1 upon 45. And the LCM for this is going to be 180, 360. So when I multiply throughout by 360, it's going to be 9 here, it's going to be 10 here, and it's going to be 8 here. Okay, so 9, 10, and 8, right? So now the question was, how much was lent to Raj? Raj was P1, R1, P1. So you have to find P1 here. So P1 will be nothing but 9 parts out of the total 27 parts, right? Into the total amount given, 40,000. So basically it was 1/3. 1/3 of 40,000 will be 13,333.33 rupees. This was the amount which was lent to Raj. Similarly, you can find out amounts lent to the other two as well using this particular approach. I hope we are clear with this question as well. You can note it down. So with this, we have come to the end of this first video. All right. So in this, we have discussed simple equations, simple interest particularly. All right. So please ensure that you have understood the concepts here and practice more of these kind of questions. All right. Also, for more such content, more such concept videos, please do subscribe to our channel. All right. On that note, let me end the session here. Thank you and all the very best.